My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 486. In this lecture, I will continue my discussion on proximity methods. So now let's go and see with example. This is the example data set and these are the proximities. Which one is example data set? This one is example data set. These are proximities or the similarities. You can think of them as distances. This one you can think as distances, because distance between 1 and 1 is 0. Just see, distance between 1 and 1 is 0, distance between 2 and 2 is 0, distance between 3 and 3 is 0, 4 and 4, 5 and 5, 6 and 6. This all principal diagonal elements are 0. Therefore, I can treat it as distances between the points. These diagonal elements all are 0. These must be distance values. Now, if you look at this matrix, let's apply min algorithm. Let's apply min algorithm on this particular matrix. I will walk through one example, which of the smallest value other than principal diagonal elements, which one is smallest value other than principal diagonal, that is 0.11, isn't it? Yes, 0.11. What is this? This is the distance between 3 and 6 in first cluster. This is the distance between 3. This is distance between 3 and 6. Therefore, this is cluster C1, isn't it? C1. Just here, 3 and 6 are in first cluster. My 3 and 6 have become one cluster. What is the next smallest value? Of course, here I have 0.11. I need not bother about it. Why? Because we already covered this one, isn't it? Now, this one is, I can say, first cluster. 3 and 6 are part of first cluster, isn't it? What is the next smallest value? If you look at the next smallest value, 0.14. Just see here. Which one is next smallest value? Next smallest value is 0.14. 0.14, it is in between 2 and 5, isn't it? Therefore, this is second cluster. This one is second cluster, isn't it? 0.14, 0.11, these two numbers are already covered, isn't it? Already taken care. 0.14 is the distance between 2 and 5. So, we can join the points 2 and 5 as cluster 2. So, this becomes my cluster 2. So, 0.14 is also taken care, isn't it? 0.14, this one is also taken care. So, 0.14 is also taken care. Next, what is the smallest value? If you look at it, what is that smallest value? 0.15, isn't it? 0.15. What is this? This is the distance between C1 and C2. 0.15, isn't it? 0.15 is the distance between 2 and 3, isn't it? Therefore, that is the distance between C1 and C2. 3 and 2 are other closest. 2 and 3 and 2 are other closest points. 3 and 2 are closest points. This is my cluster C2. This is my cluster C2, isn't it? This is my cluster C2 and this is my cluster C1, isn't it? Between these two clusters, use min approach. Similarity between 0.2 and 0.3 is 0.15. So, all these points 2, 5, 3, 6, 2, 5, 3, 6, 2, 5, 3, 6 are in my cluster 3. 2, 5, 3, 6 are in my cluster 3, isn't it? I would ask you to go through this example. Just if you take next value, what is next value? 0.22. 0.22, it's the distance between which one? Distance between 6 and 4, isn't it? That's why I'm joining 6 and 4, isn't it? Next value is 0.23. It's a distance between 1 and 6. Just I am joining, isn't it? This is the result that you will get with min clustering. Let's look at the strength of min clustering. If you have if you have shapes like this, suppose this is your original points. Let me assume these are my original point, isn't it? Suppose this is your original data input, I can say. You will get two nice clusters. I will get, this is one cluster, this is another cluster. I will get two nice clusters, isn't it? So this is, let me say, this is C1, this is first cluster. Let me write, this is C1, this is C2, isn't it? Cluster 1 and cluster 2. It works very well for shapes like this. That's what it says. Can handle non-elliptical shapes. That's what it says. Non-elliptical. Even it works. Even it works. Just see. Even it works nicely for shapes like this. Even it works nicely for shapes like this. These type of shapes, isn't it? Just let me highlight this. It works for shapes like this, isn't it? The important thing is the gap. Important thing is the gap should not, this gap, just see, this gap. The important thing is this gap should not be too small. The gap should be reasonable. The gap should be reasonable. It must be good enough. Then it works. Min also has some limitations. If you look at this original data set, for example, if the gap is very small, it will combine. My intention is just here gap should be very it must be reasonable. It must be it must not be too small. That is important. It must not be too small. The gap should not be too small. The gap should be reasonable. It must be good enough. If this is too small, then it will combine these two. That is the point, isn't it? Min also has some limitations. What is this? Just see. If you see this original data, if you look at these original points, what are the original points here? These are the original points, isn't it? If you look at this original data, it seems to have two clusters, but what is this? These two clusters. Let me say this is cluster C1. Let me say this is C1. This is C2, but lot of noise in between. Just you can see lot of noise in between these two clusters. All these are noise points. Which one are noise points? Just see, there is lot of noise, isn't it? All these are noise and outliers. In the presence of noise and outliers, what happens? It is sensitive. It is sensitive to noise and outliers. The whole noise, in the presence of noise and outliers, the whole noise will go to one of the clusters. Originally, there are only two clusters. There is a tendency in the min algorithm to combine noisy points. It keeps merging of noisy points. It's extremely sensitive to noise and outliers. Let's look at just see. It is sensitive to noise and outliers. This is the limitations of min approach. Let's look at how max works. We understand what happens in the case of max. Max basically says group 2 points. Initially every point is a cluster. Initially 3 and 6 are in cluster C1. In the case of max, what happened? Let me assume 3 and 6 are in cluster C1, 5 and 2 are in cluster C2. Now comes the fun part. I have my 4 clusters. What are my 4 clusters? In first cluster, I have 3, 6. In my first cluster, I have 3, 6. In my second cluster, I have 5, 2. In my third cluster, I have 4. In my fourth cluster, I have 1, isn't it? When you are using the max approach, the distance between C1 and C2. Just see the distance between C1 and C2. Just observe. This is C1. This is C2. The distance between C1 and C2, the similarity between C1 and C2, similarity between 5 and 6. This is Similarity between 5 and 6 is farther away compared to 3 and 4. Compared to 3 and 4 and 6 and 4. Compared to 3 and 4 and 6 and 4, and hence but the point 4 grouped to C1. This point 4 will be grouped to C1. That's what it says. This 4 will be grouped to 4 grouped to C1 and not C2. This is very important aspect. We have group C1. We have group C1 and C3. This is how max work. Just if you go through it, just you can understand how max work. Just go through this particular example. Anyway, I already provided reference link in my previous lecture. If you have any doubt, please keep a comment. I will continue my discussion in lecture number 487, in which we will discuss about advantages of max. Thank you very much.